Hey everyone, and welcome back to the channel. Today, we're diving into a fascinating process that's happening all around us, and even inside us, every single second. It's called diffusion. Sounds a bit science-y, right? Don't worry. I promise to make it super simple and fun. By the end of this video, you'll see diffusion everywhere you look. So, what exactly is diffusion? Imagine you have a bunch of super energetic kids all crammed into one tiny room. What's the first thing they'll do when you open the door to a huge, empty gym? They'll spread out, right? They'll run around until they're evenly scattered all over the place. Molecules, the tiny building blocks of everything, do the exact same thing. Diffusion is simply the movement of these particles from an area where there are a lot of them, a high concentration, to an area where there are fewer of them, a low concentration. They're just trying to find their own personal space. Let's start with a classic example. Picture a large, clear tank of still water. It's perfectly calm. Now, imagine we take a single, tiny drop of bright red food coloring and gently place it on the surface right in the middle. At first, you see a very intense, concentrated spot of red. All those red dye molecules are huddled together. But watch what happens next. Slowly but surely, that red spot begins to expand. You'll see faint red streaks start to snake their way out into the clear water. This is diffusion in action. The red dye molecules are starting to move from that crowded central spot into the surrounding water where there are no dye molecules. Let's fast forward a few minutes. That initial intense red dot is now a much larger, but fainter, cloud of red. The mass of colored water has gotten wider. The edges are blurry because the molecules are constantly jiggling and jostling their way outwards. It's not a coordinated march. It's more like a random, chaotic dance. Each individual molecule is moving randomly, but the overall effect is a net movement from the concentrated area outwards. The water molecules are also moving around, bumping into the dye molecules and helping them spread out even further. Now, let's leave it for a while. Maybe an hour. What do you think we'll see when we come back? The entire tank of water will be a uniform, pale pink color. The red dye has spread out so much that it's now evenly distributed throughout the entire tank. The mass of colored water has expanded to fill the whole container. This is the final state of diffusion, called equilibrium. It doesn't mean the molecules have stopped moving. Oh no, they're still zipping around like crazy. It just means that for every molecule that moves from left to right, another one moves from right to left. The overall concentration is the same everywhere. Let's widen our view. Literally, instead of a small tank, let's imagine a swimming pool. If we were to pour a whole bottle of that same red dye into one corner of the pool, the process would be the same, just on a much larger scale. Initially, you'd have a very dark red corner. The mass of colored water is concentrated, but over time that red would slowly creep across the pool. It would take much longer than in our small tank because there is a much larger volume of water for the dye to spread into. Days later, the entire pool might have a very, very faint pink tint. The mass of colored water has once again expanded to fill its container. This isn't just about food coloring in water. Think about the smell of baking cookies. When they're in the oven, the delicious-smelling molecules are concentrated in your kitchen, but soon they diffuse through the air, and you can smell them in the living room, and maybe even upstairs. The mass of smell gets wider. It's the same principle. Or, when you spray air freshener in one corner of a room, it doesn't just stay there. The particles diffuse until the whole room smells fresh. Diffusion is also vital for life. Oxygen from the air we breathe diffuses from our lungs into our bloodstream. The carbon dioxide we produce diffuses from our blood back into our lungs to be exhaled. Plants take in carbon dioxide through diffusion for photosynthesis. It's a fundamental process that allows substances to get where they need to go, all without using any extra energy. It just happens naturally, driven by the random motion of particles. So, there you have it, from a tiny drop of dye to the air we breathe. Diffusion is the simple, powerful process of things spreading out. It's all about moving from a crowded space to an open one until everyone is evenly distributed. Each time, the mass of the substance, whether it's water, dye, or a smell, just gets wider and wider until it fills the available space. I hope this helped you understand diffusion a little better. If you enjoyed this video and learned something new, please give it a thumbs up and hit that subscribe button for more Science Explained Simply. Thanks for watching, and I'll see you in the next one.